heart. And I'm free, free falling. Yeah, I'm free, free falling.
Hello class, today I'm going to investigate how gravity and inertia affect a falling object. We will do this by dropping two objects of different mass from the same height, and we'll see which hits the ground first. In ancient Greece, the philosopher Aristotle was thinking about these same questions. He believed that heavier objects fall faster than lighter objects. He never actually tested this idea, so we're going to see if his theory was correct. It seems like Aristotle's idea makes sense because heavier objects feel heavier when we hold them. This has to do with the force of gravity, which is the force that pulls the object down. But gravity isn't the only thing that affects how an object falls during a free fall. Another factor is inertia, which is basically the tendency of an object to stay in place and not move. The greater inertia an object has, the harder it is to move. So what does inertia have to do with falling objects? When an object is first dropped, it moves slowly due to inertia because the object wants to stay in place. So the idea for this experiment came from a mathematician by the name of Galileo, who I'm sure we all have heard of. He began to question Aristotle's theory and tested his theory by dropping two objects with different masses off of the Leaning Tower of Pisa. It is still questionable whether this experiment actually took place, which is why we will test this theory today. We will now take this experiment outside for testing. Okay, as you can see during the experiment, even though the two balls were different in mass, they hit the ground at the same time. This is because of gravity and inertia. This disproves Aristotle's theory and therefore proves that the mass of an object has no bearing on how long it will take until it reaches the ground.
Against me.